So it's not
All right.
one thing, so that makes sense. It's a total.
All right, we have continuous growth. Continuous growth looks like this. Continuous growth is in the form of a e to the kt, and you may have been introduced to this in the form of p equals p naught e to the rt, PERT. Did you remember PERT? Okay. Do you see that a e to the kt and p naught e to the rt actually say the same thing, just with different letters representing different things? Okay. All right. What is A? A is the same in both cases, and A is actually the same in this case. What is A? All right. I like Rafaela said it's the initial condition, or it is constant, but it's the initial condition. So A is the initial amount. So that hasn't changed. Okay? As a matter of fact, I want to show you something else that hasn't changed, really. Yeah, x and t are the same, actually, which means that b is really the same as e to the k, which is really the same as e to the r. It is. So, Elizabeth actually says it perfectly. B was the growth factor before. Now the growth factor for continuous growth is e to the k. And as a matter of fact, e to the k and b are the same exact way of saying it in a different way. Saying the same thing in a different way. So, here, let's take a look. What can I say? And maybe I'll also say this. K, in this case, is the growth rate. And t is time. All right? So remember before when we had a times 1 plus r to the x, r was called the growth rate. Now k is the growth rate. Do you want to ask a question, or can we do a problem maybe that'll help us figure out what questions we have? Does that work? All right, let's do a couple, maybe a problem or two to see what questions we might even have. I think I'm going to get out classwork. Whoops, I thought I was going to get out classwork. It takes longer than you take to get it out. I don't know what's going on. All right. So let me do, while I'm waiting for the classwork to come up, let me do a sample kind of problem. If I have 250 times 1.05 to the, I'll do x. Would you agree that this is an exponential equation? All right, it has an initial condition of what, Max? What's the initial value for this?
250.
Awesome. Tom, can you tell me what the growth rate is looking at this?
1.05.
You would be absolutely right if I said the growth factor. If I just want the growth rate, it's only part of your answer. Mm-hmm.
So the 105.
You're still giving me the growth factor. I actually want what you're saying, except I don't want the whole thing. So it's not the whole 105%. The growth rate is only what above 100% or below. So how much above is 105%? 5%. So this has a 5% growth rate. And this growth rate is like an annual growth rate or a daily growth rate. It's something that's measured in however many units of time you have. I can convert this to continuous growth rate very simply. Do me a favor and close your eyes just for a second. E to the k ln of 105. 0.0488. All right. Did you close your eyes? All right, you can open them. All right, I have a new function, and this is continuous growth. All right, Raphael, what's the initial condition for this continuous growth? Perfect. Maureen, what's the growth rate for this problem? Uh-huh. So Maureen looks at the 0.0488, and this is 4.8% continuous growth. Do me a favor. After 1 year, tell me how much I have for the first equation. We're going to have more or less than 250? More. 262.5? All right, the second equation, tell me how much we have after 1 year. I don't believe it. Try again. No way. 1 year. So you have to do 250 times e raised to the 0.0488. No, 1 year. After 1 year for the next one, right? So I want to show you that these actually say the same thing. In other words, Dan said that 5% annual growth rate would yield 262.5, and Maureen's 4.8% continuous growth rate yields 262.5. These say exactly the same thing. One just says it continuous growth, and the other says annual growth. And as a matter of fact, here's the link between the two. 1.05 is equal to e to the k. B is equal to e to the k. How do we solve that? Sure. Sam? Yeah, you can totally do logs. Now, here's where I'm going to, so good answer. I'm going to be a little bit more specific this time. In this instance, when we have a base e, we should take the natural logs of both sides. Because on the right-hand side, when I bring down the k, what's the natural log of e? The natural log of e says, Gesundheit, e raised to what power gives me e? 1. No, 1. E to the 1 gives me e. So the natural log of e is, this is the same as 1. So this tells me k is equal to the natural log of 1.05. What is the natural log of 1.05? Go ahead, do it on your calculator. Find the natural log button. 0.0488. Did you find the natural log button on your calculator? Yeah. Andrew, you did not find the natural log button on your calculator. Yeah. Where is that natural log button? All right, so the natural log button is right above the store button. Do you want to ask a question? Do 14. What's going to be the same? 14. You'd be right if we're doing 50. 14. 5's going to be the same. Did I say 15? All right. Maybe I said 15 to that half of the room and 14 to this half. Sorry. What is B? How do you do B? I can't. It's impossible. Jen, what do you get for B? 0.53. Oh.
Same as 0.47 is the growth rate.
Isn't it 0.047?
Here it is. This is equal to B.
0.4.
Oh, so you add 1.
No. This whole thing is equal to B. Right? So I'm not doing, remember, a continuous growth rate is different from an annual growth rate. Now, Jen's saying maybe it's going to be close to 0.53. Because I know what you did. What did you do, Jen? You took 1 minus. Now this growth rate's telling me it's decreasing at 47% continuously. What do you get for B when you actually do this? 0.625. How? You need to do that, right? That is B. There's no it's not a secret. I'm not trying to make you be clever. I'm just saying e to that is B. So hold on. 1 second to recap. These two functions now are the same thing. They say something slightly differently. One says that the growth rate is decreasing 47% continuously. The other one says we're decreasing, what's that, 37? Sit. On the chair. Sit down. The other is saying we decrease 37.5% annually. Do you see how this says we're decreasing 37.5%? Would you agree that this one looks more like the rate's decreasing? Like it's actually telling you it's decreasing. All right. Thanks for the extra minute. Have a great day.
I have a question.
What do you have?